Welcome to the Deep Dive. Today, we're tracking a cosmic mystery. It's 5 billion light years away. We're talking about OJ 287, this brilliant, almost engine-like thing in the universe that's, well, it's baffled observers for more than 150 years. Yeah, seriously, ever since we got reliable records back in the 1880s, this distant galaxy has been, kind of famous for its really unusual, dramatic changes in brightness. It just flares up, flickers violently, and for decades, scientists they only really had guesses, hypotheses about why. So our mission today is to unpack this brand new breakthrough image. And it's not just like a slightly better picture. No, this is basically visual confirmation. It gives us the clearest evidence we've ever had for this molecular violent truth that's hiding right at the galaxy's core, which is a pair of merging supermassive black holes locked in this kind of cosmic dance.
That's exactly right. And the source material for this deep dive, it really centers on this unprecedented image. It was captured by an international team led by Dr. Efthalia Trianou over at Heidelberg University. And this finding, it isn't just about confirming something we kind of suspected. It's really about opening a brand new door into the physics of how black holes interact and the extreme cosmic conditions they cook up.
Okay, let's set the scene a bit then. Why has OJ 287 been so mysterious for so long? And what exactly is it? We threw the name out there, OJ 287. Does that actually mean anything specific?
Yeah, the name itself, OJ 287, it actually points back to how it was found. The O is for the Ohio Sky Survey, where it was first cataloged. And the J, well, that links to later observations from Joe Drill Bank. But what really defines it, physically speaking, is its classification. It's a blazar. And for listeners, maybe just a quick refresher, blazar is a very specific incredibly luminous type of active galactic nucleus, an AGN. So that means you've got a supermassive black hole right at the center of the galaxy, and it's actively pulling in, accreting matter. But the really crucial part for a blazar is that it's extremely powerful plasma jet. It's pointed almost directly towards us, towards Earth. And that makes its light output seem incredibly bright and energetic from our perspective.
Okay, that explains the brightness, the sheer power of it, but not the flickering, right? If the jet's pointed right at us, why would the light change so much over time?
And that has been the puzzle for, 150 years. The, let's say, conventional wisdom for a single blazar just wouldn't explain the specific, almost, periodic nature of OJ 287's brightness changes. So the leading idea, the main hypothesis for decades, was that the only way you could really cause such predictable, massive disruptions was if there were two supermassive black holes orbiting each other in there. The thinking was you'd have a primary, really big central black hole doing most of the work, generating the main jet. And then you'd have a secondary, maybe smaller black hole orbiting it. And as that secondary one swings through the accretion disk of the primary, bam, it violently stirs up all that matter. That causes the flares, the fluctuations that we see as these extreme changes in brightness. It was a gravitational explanation needed to make sense of the light curve. But until now, we just didn't have the visual proof of that mechanism really happening.
Right. So we knew the light was chaotic, maybe even predictably chaotic. We suspected this binary system was the cause, but we couldn't actually see the two black holes themselves, just the fireworks, the flares they caused. Okay, let's talk about those jets then, because that's what this new image really zeroes in on. What's the basic mechanism driving them? How do black holes even make jets?
Well, the black hole's gravity is obviously immense, but the energy being released is just equally mind-boggling. When the supermassive black hole pulls in the surrounding gas and plasma, that's its accretion disk, there are incredibly powerful magnetic fields very close to the event horizon. These fields can kind of grab some of that charged matter and basically fling it, accelerate it away from the poles at speeds incredibly close to the speed of light. And these aren't just, streams of light. They are vast, focused outflows of plasma. They're made of extreme heat, intense radiation, heavy particles, and magnetic fields so powerful they literally organize matter on galactic scales. It's like the exhaust from some colossal cosmic engine.
And the big news, the revelation of the source material, is that this new tech let us see past all that bright glare, right into the detailed structure of that exhaust. So what did the image actually show that was so groundbreaking? It revealed, for the very first time in OJ 287's history anyway, this previously unseen structure. It's described as a sharply curved, ribbon-like structure in the plasma jet coming out from the core. So yeah, it's not just a straight beam of fire like you might imagine. It's warped, it's bent.
Exactly. Dr. Trianou's team, they stated very clearly this level of detail, it had simply never been observed before in OJ 287. If you usually think of a jet as like a straight laser beam, seeing a sharp curve in it is Well, it's like seeing a footprint in fresh snow. It immediately tells you that some external moving influence is constantly tugging on the jet's direction.
That's a huge observational leap.
Yeah.
Okay, so before we dig into what that curve means, we have to pause and just marvel at the technology, right? The tech that made this footprint visible from 5 billion light years away. How on Earth or off Earth did they capture an image with this kind of sharpness, especially in the radio range?
They use a technique called ground space radio interferometry. Interferometry basically, it combines signals from multiple telescopes that are really widely separated. And by combining them, you effectively mimic one enormous virtual telescope. The wider the separation, the sharper the view. And to get this extreme resolution, the team used the Radioastron mission. That's a 10-meter antenna on the Spectre-R satellite way out in Earth orbit, and they synchronized it perfectly with a huge network of ground observatories. I think it was 27 radio telescopes spread across the entire surface of the Earth.
Okay, this is where the scale just gets genuinely astonishing. By syncing up all those telescopes, the one in space, the 27 on the ground, they created a virtual space telescope with an effective diameter way, way bigger than our planet. Yeah, the sources point out that the diameter of this virtual scope was 5 times greater than the actual diameter of the Earth. That incredible scale, that huge baseline, that's why they got such high resolution. They didn't just make the image bigger, they made it sharper. So sharp they could finally resolve these internal structures in the jet that were just blurred or invisible before.
Precisely. And that sharp image, it immediately gave us new insights into the jet's behavior, its physics. That sharply curved, ribbon-like structure. It points directly to the physics we suspected all along. It confirms that the movement of an orbiting object, that secondary black hole, is constantly influencing the plasma jet's trajectory. It's causing this phenomenon we call precession, or basically a wobble.
And the analysis of the plasma in that jet revealed conditions that are, they're almost incomprehensible. Let's talk about the temperature for a second. The sources note that some regions of that jet exceed temperatures of 10 trillion degrees Kelvin. That sounds like a typo. How do we even start to grasp that kind of energy?
It is genuinely difficult. For perspective, the core of our own sun, that's only about 15 million degrees Kelvin. We are talking about temperatures that are literally millions of times hotter, 6 orders of magnitude hotter. The reason it gets so extreme is that the matter inside the jet, it isn't just hot. It's being accelerated to relativistic speeds.
Yeah.
Speeds very close to the speed of light as it interacts with these intense magnetic fields and shock waves coming from the black hole system. This temperature, it's crystal clear evidence of just extreme energy transfer and particle acceleration happening right near those black holes.
Wow. Okay, so beyond confirming the unbelievable heat, how did actually seeing the curve and the jet structure help connect the dots with older data? Did it explain anything else?
Yes, and this is where putting all the pieces together gets really compelling. With this sharp image, the researchers could visually track something specific. The formation, the spreading, and then the collision of a new shockwave traveling along in that curved jet structure. And this shockwave event, visible right there in the radio image, it lined up perfectly, correlated perfectly, with an energy event that was recorded years earlier. Specifically, it matches up with a massive, extremely high-energy gamma-ray burst that was detected back in 2017. That burst released energy in the trillion electron volt range, the TeV range. Now, before this new image, that TeV measurement was just sort of this unusual, unexplained data point. But now, the visual evidence confirms how that energy was released. It was the formation and collision of this new shock front within the jet, almost certainly triggered by the secondary black hole interacting with the primary's accretion disk. The new image basically provides the why for that old measurement.
Okay, so let's pull this all together then. What does it mean for the big picture? We started with this century-and-a-half-old mystery about flickering light. Then there was this long-held hypothesis about 2 black holes causing it. And now we have this stunning, curved, 10 trillion degree ribbon of plasma that not only looks amazing, but actually explains a previous unexplained energy spike. So the interferometric image, the picture of that visually curved jet structure, it really does unequivocally underpin that long-standing assumption, doesn't it? That a binary supermassive black hole system is indeed sitting inside OJ287. The curve is basically the signature, the fingerprint of the secondary black hole's orbit, just etched into jet itself.
Exactly, nailed it. The image gives us crucial information on how the incredibly dynamic movements of such a massive pair of orbiting objects actually influence the shape, the form, the orientation of the plasma jets they emit. When you have 2 supermassive black holes orbiting each other, their combined gravity just warps everything, space, matter around them. We are literally seeing that gravitational tug of war reflected in the physical shape of the jet. But the implications, they go way beyond just understanding this one system, OJ287. Dr. Triano really emphasized this. OJ287's special properties. The fact that it is a confirmed binary system, that its powerful jets are something we can actually map clearly, even 5 billion light years away. All this makes it an absolutely ideal candidate for doing more research into merging black holes in general.
And if we can track how their movements influence the jet structure over time, what does that tell us about the final stages, the merger itself?
Well, crucially, this kind of research gives us this unique, multifaceted look at the very systems that are actively generating the most powerful ripples in space-time we know of, gravitational waves. Detecting those waves is huge, but understanding their sources better is key. And this is one of the ultimate cosmic events, right? The spiraling inward and the eventual incredibly violent merger of two supermassive black holes. So by understanding how their dance, their movement imprints itself onto the jet structure, we can get much better predictive models. Models for the strength, the frequency, the timing of the gravitational waves that will be released when they finally do collide. It really moves the discussion from just observation, looking at things, to actually predicting the outcomes of this kind of cosmic violence.
That is absolutely incredible. So just to wrap up the core takeaway for you, the listener, this single incredibly detailed image captured by creating a virtual telescope 5 times the size of Earth, which is still amazing, finally confirms a binary supermassive black hole system 5 billion light years away. It proves that the 150-year flickering mystery of OJ287 was caused by this pair of cosmic giants. And at the same time, it gives us visual confirmation of the physics driving matter hotter than 10 trillion degrees Kelvin. Just mind-bending stuff.
And if the movement of these two black holes directly dictates the specific curved shape of that plasma jet ribbon, well, it raises a really important question for future research, doesn't it? What new, even finer grained details could the next images reveal about that final violent dance leading up to the merger, and the huge gravitational waves that will come from it? As they spiral tighter, as their gravitational influence becomes even more intense, what kind of complex patterns might we actually see etched into the cosmos? Almost like a final warning sign before they collide. That's the kind of knowledge we're really only just beginning to access now.